Hello, Year 7. Hopefully you have completed all the work on area of rectangles because today we're going on with the area of triangles. So one side of a triangle is called the base, which we give the letter B, B for base. The perpendicular distance from the base to the opposite vertex or the opposite angle is called the height, which we give the letter H. Now, I've got a diagram under here for you with 3 different ways that this could look. So you have your first triangle here where you've got a right angle in the corner and you've got your base down the bottom and the height is the one going up from that right angle. In the second one, the base is obviously across the bottom again, but the height is the perpendicular one that goes to that vertex straight across. And in the third one, this is the one that often catches people, there's no right angle at all in the triangle. To get a right angle, they've actually extended out the bottom side to get a perpendicular height up here. Now the key thing is with a triangle is to use the formula. It is always the 2 sides, the base and the height are always the 2 sides that are connected with the right angle. The only catch with that, I guess, is this third one. When you're doing the base, it's only this part of the base, you don't find that extra dotted part, but it's the base and the perpendicular height, the 2 sides that are connected by that right angle. Okay, so this is the formula for the area of a triangle. A equals half of base times height. Now, hopefully you're thinking that looks pretty close to the rectangle formula. The formula for a rectangle was A equals BH. Well, a triangle is half of a rectangle. If I took this triangle here and turned it into a normal rectangle like that, these 2 triangles would be the same, and so one triangle would be exactly half of that rectangle. And even though these other ones are a little bit stranger in size, the way that they've been drawn, the triangle is always half of the rectangle that would go around it. Okay, so you can use that to help you remember the formula. So we have a couple of questions down here. Number 1, find the area of the triangle shown below. Show full working out. So like always, start by writing your formula down. I know it's a triangle, so I know I need the formula A equals half BH. The base and the height, I look for this right angle, and I know that it's the 2 sides that are joining that right angle. Now in these questions, I haven't tried to be particularly tricky, but because there's only 2 sides that you could use really. In some questions though, they deliberately give you extra measurements on your diagram to try and trick you into using the wrong ones. So always look for that right angle so that you pick the right sides to use. So substituting in, I would have half times, remember there's times in between each of the things, the base is 10 and the height is 9. Timesing those together, half times 10 times 9 is 45, and the units will be centimeters squared. For part B, it's a triangle again, so we write the formula down. A equals half BH. So the right angle is over here. The 2 measurements that I need are the 9 meters and the 6 meters that are joining up that right angle. So substituting into the formula, half times 9 times 6 times that all together, and you get 27 meters squared. Okay, so most of your questions, a lot of your questions will be like that. Here is a slightly trickier one though, question 2. A church spire, which is the roof of this building over here that you can see in the picture, has 6 identical triangular faces with the dimensions shown. It's a little bit little, but hopefully you can see that we have 100 centimeters for the base of the triangle and 4.2 meters for the perpendicular height of that triangle. What area of copper roofing would you need to cover all 6 faces of that spire? Well, we know we want to find the area of one of those triangles to start with. So the area of a triangle is always half base times height. Now, the first problem we have is that my dimensions of my triangle are actually in different units. I have 100 centimeters and 4.2 meters. Now the question hasn't told me which unit I should use, so I need to choose. Now you're not incorrect if you choose differently to me. You just need to make sure, as always, that you include the unit in your answer, and that should make everything work out correctly. So I'm going to change the 100 meters because that's a very easy conversion. That one, 100 centimeters is exactly 1 meter. Okay, so that's a nice easy conversion to do. I'm going to sub that into my formula. So I have half times my base, which is 1 meter, and my height, which is 4.2 meters. Times all of that together, we have half times 1 times by 4.2, which is 2.1 meters squared for the one triangle. If I wanted to cover that whole roof, that whole church spire, I remember I have 6 identical triangular faces. So the total amount of copper that I'm going to need to cover that is going to be 6 lots of, or 6 times by the 2.1, which is 12.6 meters squared. Okay, so that's it for today on triangles. Exercise 8 of your workbook, pages 24 to 27.